Welcome students. Today I am going to start one of the important chapter P block elements. So let's start. P block elements, the elements belonging to groups 13 to 18. They are known as P block elements. Here in this periodic table we can see that the P block is this from group 13 element to group 18 element, from boron family to inert gases or noble gas family from group 13 to group 18, and they have the general electronic configuration ns2 and p126. As in P block element there are 6 group 18 to group 13 to group 18 there are 6 group. So the number of electron which can maximum be filled in p orbital, that is from 1 to 6, and we know that the maximum number of electron in a p orbital can be 6. Now it includes all the three types of elements. P block includes all the three type of element like metals, non-metals and metalloids. So this is the general introduction about the P block element. We know that as there are maximum tendency of electron in P block is 6, and we know that there are 6 group in the periodic table and it is from 13 to group 18. As in 11th class, we have already learned about two groups. One is group 13 and group 14. We have already discussed these two groups in class 11th. Now in class 12th, we have to discuss group 15, group 16, group 17 and group 18. Now first of all in this video we will discuss group 15 elements first. So let's start with group 15 elements. Group 15 elements. Group 15 includes the elements nitrogen, phosphorus, arsenic, antimony and bismuth basically, and there is a new addition of a new element and its atomic number is 1115 and that element is moscovium. So let's start with occurrence of group 15th element. The molecular nitrogen comprises 78% by volume of the atmosphere, and it is not very abundant in the earth crust. In the earth crust, it occurs as sodium nitrate NaNO3, Chile saltpeter, it is also known as Chile saltpeter, and potassium nitrate KNO3, which is known as Indian saltpeter. As we know that nitrogen is present in air, so the maximum amount of nitrogen is in air rather than in the earth crust. And in the earth crust, nitrogen is basically present in the form of sodium nitrate, which is known as Chile saltpeter, and in the form of potassium nitrate, which is known as Indian saltpeter. Now come to the next. Phosphorus occurs in mineral of a apatite family and in the form of Ca9PO4 6.CaX2, where X is fluorine, chlorine or OH, which are main components of phosphate rocks. Phosphorus is present in bone as well in living organisms or animals and plants. And as we come to arsenic, antimony and bismuth, they are found mainly in sulfide minerals. So this is about occurrence of group 15 elements. Now come to the general characteristics of group 15 elements. Now come to the electronic configuration. The atoms of group 15 have 5 electrons in the outermost shell, 2 electrons in S and 3 electrons in P subshell. And due to this, the electronic configuration of this group is Ns2np3, and we know that the electronic configuration for general electronic configuration for P block element is Ns2np126, and for group 15 it comes to be Ns2np3. Now let's see some electronic configuration of these elements. First is nitrogen, and we know that atomic number of nitrogen is 7 and the group number of nitrogen is 15, but the period number of nitrogen is 2. So for this, the electronic configuration of nitrogen will be 1s2, 2s2, 2p3, And we know that 1s2 is the electronic configuration of a noble gas, and that is helium. So here the electronic configuration of nitrogen can be written as helium 2s2 2p3. Similarly, as we move down the group, we come to the phosphorus, whose atomic number is 15, and as atomic number is 15, group number is 15, but the period number is 3. So for phosphorus, the electronic configuration is neon 3s2 3p3. Since period number is 3, therefore it is the last electron will move, the last subshell, the last cell for phosphorus will be 3s and 3p. And as we come to arsenic, the atomic number is 33 and the electronic configuration is organ 3d10 4s2 4p3. हमने 11th क्लास में हमने एक लॉ वहाँ पे पढ़ा था, अफबाउस प्रिंसिपल। जो इलेक्ट्रॉन फिल होते हैं अफबाउस प्रिंसिपल में, अफबाउस प्रिंसिपल के अकॉर्डिंग ही किसी भी एटम में इलेक्ट्रॉन की फिलिंग की जाती है। तो जो इलेक्ट्रॉन्स फिल होंगे, क्योंकि फॉस्फोरस से हमारा थर्ड शेल स्टार्ट हुआ, तो अब जब हम आर्सेनिक में आए तो उसका जो पीरियड नंबर है डेट इज 4, तो यहाँ पे थर्ड शेल था, तो थर्ड शेल में जो सब शेल है वो वहाँ पे डी सब शेल की भी एंट्री होगी और डी सब शेल में भी इलेक्ट्रॉन फिल होंगे, ये चीज़ हमने देखी थी। और जो इलेक्ट्रॉन फिल होंगे वो अकॉर्डिंग टू द अबाउस प्रिंसिपल होंगे, तो पहले इलेक्ट्रॉन 4s में फिल होगा, देन आफ्टर इट विल बी फिल्ड इन 3d. So the electronic configuration for arsenic, it is organ 3d10 4s2 4p3. Similarly for antimony, atomic number is 51 and the electronic configuration is krypton 4d10 5s2 5p3. And as we come to the bismuth, atomic number is 83 and the electronic configuration comes to be xenon 4f14 5d10 6s2 6p3. Here the 4, since the fourth shell is there, so the subshell for 4 shell is F is also there, F block, F subshell is also there, D subshell is also there, S and P are also there for bismuth. So this is the electronic configuration of group 15th element. Come to the next characteristic, atomic and physical properties. In atomic and physical properties, the first property which we will discuss is atomic and ionic radii. On moving down the group, in a 15 group, as we move down the group, atomic radii increases due to increase in number of shell. As we know that, and in general, in a periodic table, as we move down the group, जब हम ग्रुप में डाउनवर्ड मूव करते हैं तो हमारा जो एटॉमिक रेडियाई होता है एटम्स का वो इंक्रीज करता है। क्यों? क्योंकि एज वी मूव डाउन द ग्रुप शेल नंबर इंक्रीजेस। अभी हमने शेल नंबर्स देखे थे, हमने पीरियड नंबर देखे थे, बिकॉज पीरियड नंबर इंक्रीज कर रहा था हमारे ग्रुप एलिमेंट्स का नाइट्रोजन टू बिस्मथ, तो शेल नंबर ऑल्सो इंक्रीजेस। फॉर नाइट्रोजन द शेल नंबर इज 2. Electronic configuration is helium 2s2 2p3, and for bismuth the shell number becomes 6. And from here we know that as we move down the group the shell number increases, and due to increase in shell number atomic radii also increases, and similarly ionic radii will also increases. Now however, from arsenic to bismuth only a small increase in covalent radii is observed. होता क्या है, जनरल फॉर्म में तो एटॉमिक रेडियाई इंक्रीज कर रहा है, बट जब आर्सेनिक एंड बिस्मथ की बात करें, आर्सेनिक से बिस्मथ तक जाने के में केवल एक स्मॉल इंक्रीमेंट हो रहा होता है एटॉमिक रेडियाई में, एंड दिस इज ड्यू टू द प्रेजेंस ऑफ कंप्लीटली फिल्ड डी एंड एफ ऑर्बिटल्स इन द हेवियर एलिमेंट. एज वी हैव ऑलरेडी discussed the electronic configuration of all the elements of group 15, and we observed that the orbitals of arsenic to bismuth, the entry of F and D orbital was there, and the F and D orbital from arsenic to bismuth are completely filled, and due to the completely filled and due to its completely filled nature of D and F orbital, the atomic radii or covalent radii is increases but in a small amount. This can be seen in this data also. Atomic radii for nitrogen is 70 and it is increases as we move down the group, but you can see here from arsenic to bismuth this increment of the radii is in a very small extent. Why it is so? It is due to the completely filled D and F orbital in arsenic to bismuth. And Here also, if we compare group 15 with group 14 elements, now the atomic radii of group 15 are smaller than group 14 element. Why? As we know that in general, as we move from left to right in a periodic table, the atomic radii is generally decreases, and we know that group 15 is present at the right hand side of the group 14 element, and in a periodic table the atoms which are elements which are present on the right hand side will have the less atomic size. And the for reason behind this, since the nuclear charge of group 15 element is larger, and as the nuclear charge larger, the atomic size will get decreases than the group 14 elements, and as the nuclear charge increases, the electrons are strongly attracted by the nucleus, and therefore atomic radii will get decreases. क्योंकि न्यूक्लियर चार्ज बढ़ेगा, न्यूक्लियर चार्ज का मतलब उसके ऊपर पॉजिटिव चार्ज का इंक्रीमेंट, और अगर न्यूक्लियर चार्ज इंक्रीज होगा तो उस ग्रुप के जो एलिमेंट्स होंगे उनका इलेक्ट्रॉन की साइड को अट्रैक्शन ज़्यादा होगा, और जितना कोई एलिमेंट इलेक्ट्रॉन की साइड को अट्रैक्ट करेगा या इंटरेक्ट होगा तो उसका जो साइज होगा एटम का, वो साइज क्या करेगा, डिक्रीज करेगा, कॉन्ट्रैक्ट हो जाएगा। और जब अगर साइज डिक्रीज हो रहा है तो इट मीन्स एटॉमिक और आयनिक रेडियाई भी उस पर्टिकुलर एटम का डिक्रीज होता है जब हम पीरियोडिक टेबल में लेफ्ट टू राइट मूव कर रहे होते हैं, या फिर इफ वी आर कंपेयरिंग ग्रुप 15 एंड ग्रुप 14, सो ग्रुप 15 एलिमेंट विल हैव लेस atomic and ionic radii as compared to group 14. Next property is ionization enthalpy. Ionization enthalpy decreases down the group due to gradual increase in atomic size. As we know that ionization enthalpy is inversely proportional to atomic size. As the atomic size increases down the group, the ionization enthalpy will get decreases. Now this can be seen by this data also. First ionization enthalpy of nitrogen is 1402 kilojoule per mole, whereas it is for phosphorus it is 1012 kilojoule per mole. Now what will happen, on increasing the size from nitrogen to bismuth, the ionization enthalpy gets decreases. And as we know that the ionization enthalpy is inversely proportional to atomic size, क्योंकि साइज इंक्रीज हो रहा है टॉप टू बॉटम जाने में ग्रुप 15 में, तो उसकी आयनाइजेशन एंथैल्पी जो एटम्स की है वो डिक्रीज करेगी। एटम्स के जो आयंस में कन्वर्ट होने की जो एनर्जी की रिक्वायरमेंट है, जितनी एनर्जी की रिक्वायरमेंट है वो एनर्जी डिक्रीज करने लगेगी, बिकॉज साइजेस इंक्रीजेस एज वी मूव टॉप टू बॉटम. Now what will happen with the ionization enthalpy of group 14 and group 15? The ionization enthalpy of group 15 elements are higher than the corresponding members of group 14 element. Now why it is so? The larger ionization enthalpy is due to the greater nuclear charge. We know that higher nuclear charge is for group 15 element, and group 15 element, due to higher nuclear charge, their atomic size is small, and they have stable configuration of the atom of group 15. And as the electronic configuration of group 15 is stable, we know that for group 15 the configuration is ns2 and p3, which is a stable electronic configuration because p is half filled here, and the half filled orbital have extra stability, and due to the extra stable half filled p orbital, the ionization enthalpy of the 15 group element will be higher. To break the atom into their ion, we have to require more energy. Due to their extra stability, we have to require more energy to break the atom into its ion. So group 15 element have higher energy as compared to group 14 element. Next is electronegativity. The electronegativity value decreases on moving down the group and is due to increase in the size of the atom. Also here the electronegativity is inversely proportional to the size of the atom. As we move down the group, electronegativity again decreases on increasing the size of the atom. However, amongst the heavier elements, the difference of electronegativity is not that much pronounced. And you can see in this data also the electronegativity of nitrogen is 3 and it is decreases up to arsenic and it is decreases up to bismuth as well, but the electronegativity of these higher elements is not, they have not a much difference, they are almost equal. Why it is so? It is because as we move down the group, atomic size increases and also the shielding effect of inner electron shell is also increases. Shielding, as we move down the group, shielding effect is also increases because of the filled d and f orbital. Shielding effect is also increases, and as the shielding effect increases, the contraction in the size of the element will be there, and as the contraction of the size, then the size will get लेस एज कम्पेयर टू द प्रीवियस एलिमेंट, और जैसे ही वो साइज अपने प्रीवियस एलिमेंट से कम होगा, साइज कम होगा, तो इलेक्ट्रोनेगेटिविटी की जो वैल्यू है उसमें ज़्यादा डिफरेंस नहीं आ पाए, डिक्रीज होगी इलेक्ट्रोनेगेटिविटी बट उतने ज़्यादा अमाउंट में, उतने ज़्यादा उसके वेरिएशन के साथ डिक्रीज नहीं होगी. नाउ लेट्स सी व्हाट विल बी द वेरिएशन ऑफ इलेक्ट्रोनेगेटिविटी ऑफ ग्रुप 14 and 15. The electronegativity of group 15 are higher than the corresponding group 14 element. Again it will depend upon the size. We know that group 15 element have a smaller size, and due to their smaller size they have greater nuclear charge, and as they have greater nuclear charge their electronegativity values will be higher. Metallic character. On going down the group, metallic character increases from nitrogen to bismuth. And nitrogen and phosphorus are non-metals. Arsenic and antimony are partially non-metals, or they come to the category of metalloids, while the bismuth is metal in this 15 group element. Bismuth is only a metal in 15 group element. Next property is melting and boiling points. The melting point of group 15 elements first increases from nitrogen to arsenic. This is important. Melting point first increases from nitrogen to arsenic and then decreases to antimony to bismuth. As we know that melting points means to convert a solid into a liquid form, and that temperature is known as melting point. Now what happened in 15 group element, generally this melting point firstly increases from nitrogen to arsenic, but it goes decreases and then it goes decreases from antimony to bismuth, and the melting point increases down the group. Generally the melting point increases down the group due to increase of atomic size. We know that the melting point is directly proportional to atomic size. अगर एटॉमिक साइज बढ़ता है तो मेल्टिंग पॉइंट बढ़ता है उस पर्टिकुलर कंपाउंड का, क्योंकि जितना उसका बड़ा साइज होगा उसको मेल्ट होने के लिए उतनी ज़्यादा टेम्परेचर की रिक्वायरमेंट होगी, तो मेल्टिंग पॉइंट बढ़ेगा. लेकिन इस 15 ग्रुप में कुछ ऐसा नहीं होता. यहाँ पे नाइट्रोजन से आर्सेनिक में आएंगे तो मेल्टिंग पॉइंट बढ़ता है, बट एंटीमनी और बिस्मथ के केस में फिर मेल्टिंग पॉइंट डिक्रीज हो जाता है. ऐसा क्यों? जो बढ़ना चाहिए था वो कम हो रहा है. ये इसलिए ऐसा अनएक्सपेक्टेड डिक्रीज इसलिए यहाँ पे शो हो रहा है. क्यों? क्योंकि यहाँ पे जो इफेक्ट लग रहा है, दैट इफेक्ट इज इनर्ट पेयर इफेक्ट. अगेन वी हैव डिस्कस्ड अर्लियर जो इलेक्ट्रॉनिक कॉन्फ़िगरेशन इन 15 ग्रुप एलिमेंट्स का, उन इलेक्ट्रॉनिक कॉन्फ़िगरेशन में जो डी एंड एफ ऑर्बिटल का कंप्लीटली फेल्ड जो डी एंड एफ ऑर्बिटल हो रहे हैं, उनकी वजह से वहाँ पे कॉन्ट्रैक्शन आ जा रहा है, एंड ड्यू टू दैट कॉन्ट्रैक्शन inert pair effect developed, and due to inert pair effect this antimony and bismuth forms only 3 covalent bonds instead of 5 bonds. All the other element of group 15 can form 5 bonds. वो तो 5 बॉन्ड फॉर्म कर सकते हैं अप टू आर्सेनिक तक, क्योंकि उनका जो लास्ट जो इलेक्ट्रॉन्स है वो 5 इलेक्ट्रॉन्स है उनके लास्ट शेल में, 2s2 2p3 और ns2np3. लेकिन जो एंटीमनी एंड बिस्मथ है, इनका जो साइज एटॉमिक साइज बढ़ने की वजह से जो है कॉन्ट्रैक्शन आ रहा है, जिसकी वजह से केवल 3 बॉन्ड्स ही फॉर्म कर सकते हैं, एंड एज अ रिजल्ट द अट्रैक्शन अमंग देयर एटम्स इज वीक. उनके एटम में अट्रैक्शन वीक होगा, एंड ड्यू टू दिस इनका जो मेल्टिंग पॉइंट है वो डिक्रीज हो जाता है. एंड इन केस ऑफ of boiling point in general increases from top to bottom in the group. It will increases from nitrogen to bismuth as usual. And what is boiling point? Boiling point is the conversion of liquid to the gaseous form. We can say that the temperature to boil which is required to boil a liquid, that will be known as a boiling point, and in general boiling point increases from top to bottom in group 15. Next is allotropy. Except nitrogen and bismuth, all other elements of this group show allotropy. Phosphorus exists as white, black or red phosphorus. You can see in the image, phosphorus, three allotropes of phosphorus are available: white phosphorus, black phosphorus and red phosphorus. Arsenic exists as yellow or grey arsenic. Arsenic can have two allotrope, yellow and grey. Similarly, antimony also has two allotropes, yellow or a silvery grey. So here in this table you can see the atomic and physical properties of group 15 element, the variation of different properties with the elements in this table: boiling point, melting point, atomic number, atomic masses, electronic configuration, ionization enthalpy, electronegativity, covalent radius, atomic radius or ionic radius as well. And here from this table we can also say that the density of group 15 element increases as we move down the group. Density is increases because atomic mass is increases. You can see in this second point atomic mass is given, and atomic mass of nitrogen of group 15 nitrogen to bismuth, it is increases from 14012 to 208.98 for bismuth. And as the atomic mass increases, density of group 15 element also increases as we move from nitrogen to bismuth or as we move down the group. Now it's question and answer time. So question is, in group 15 elements there is considerable increase in covalent radius from nitrogen to phosphorus, but a small increase from arsenic to bismuth. Why? We have already discussed atomic and ionic radii. So why this is so? Answer is, this is due to the completely filled d and f orbitals in arsenic, antimony and bismuth. In arsenic the completely filled d orbital is there, that is 3d10, and in antimony the completely filled d orbital is also there, 4d10. In bismuth there is completely filled d orbital as well as completely filled s orbital, and due to these completely filled d and f orbital, the contraction in the atomic radius of these elements will be there, and as the contraction will be there, the tendency of electron to attract towards the nucleus will be larger, or as the electrons are more attracted towards the nucleus, their size will get compact or will get and we will show a small increase from arsenic to bismuth. So this is all about today. I have some questions for you. Do these questions and we will discuss our next property in our next video. So here are some questions. Question first. The ionization enthalpies of group 15 elements are higher than those of corresponding members of group 14. Give reason. Question second. Explain melting point trend of group 15 elements. And the third one is, why the electronegativity values of group 15 are higher than the corresponding group 14 elements. So you have to answer these three questions, and we will meet in our next video with our new properties. So keep watching. Thank you.